Hello, in this video, we're going to review the basic notation of differentiation. At the basic level of calculus, we're only going to deal with these two types of notation. These are Lagrange's notation and Leibniz notation. There are two more types of notation. Those are Euler's notation and Newton's notation, but those are not of interest to us at the basic level. They appear in other courses. If you come across them in the future, once you understand the ones that we're going to learn today, those are, you can transition to them very easily. So in order to explain these notations, we're gonna let f be a function, and we're gonna start with Lagrange's notation, which uses an apostrophe to indicate the derivative, and we call it prime. For example, the first derivative is f prime of x. The second derivative is gonna be f double prime of x. The third derivative is going to be f triple prime of x. We use these three apostrophes. And at the fourth derivative, we no longer use the prime symbol. We're just going to indicate the order of the derivative with the number. So after that, if we have n order derivative, so f, this is the nth derivative of f of x. Leibniz notation is a little different. It looks like a fraction, and it looks like this. For example, the first derivative is gonna be d dx, which indicates the derivative of the function with respect to x. For the second derivative, we're just gonna use they're not exponents, but they look like exponents, but they're not. This is the second derivative, and you follow the same format for the higher order derivatives. For example, the third derivative. And notice that we enclose the function in brackets. And here we have the fourth derivative. So very simple, as we can see here. Each notation has its own advantage. Like Lagrange's notation, for example, is very simple to follow. And for Leibniz notation, it comes handy when you're doing other calculus operations, such as integration, which is the the integration is antiderivatives. So it's gonna come in handy once you go into higher level topics of calculus. So this is, as you can see, very simple. And let's look at some examples. So how we can use this notation. For example, let's say example 1, find the first, second, and third derivatives of f of x. And let's let f of x be some type of function. Let's say f of x, let's say x plus 1 cube. So let's just do it. We can apply chain rule to solve this derivative. So the first derivative is going to be 3 times x plus 1 squared. Second derivative, use the double prime symbol, and 6 x plus 1 times x plus 1. And for the third derivative, I use, it's just going to be only 6. So very simple. And let's do another example. We're going to use the Leibniz notation. Example 2, find the first, second, and third derivatives of f of t. Just gonna use f of t as the function. So let f of t be, for example, t cubed. Let's just make something up. 5t squared plus 4t minus 2. So now let's use this Leibniz notation, d dt of f of t. That's the first derivative. It's going to be 3t squared minus 10t plus 4. Now let's do the second derivative. We use this exponent-like notation. And this becomes 6t minus 10. And finally, the third derivative. So the 3 indicates the third derivative of f of t, and which is 6 as well. So yeah, so these two examples show how we can use Lagrange's notation, and this one, the Leibniz notation. So I hope this was helpful, and see you next time.